Good afternoon to all of you. First of all, I want to introduce myself. Myself Ankit Acharya, working as an assistant professor in Hasmukh Goswami College of Engineering, and today my content is GTU question paper solution of the subject of vector calculus and linear algebra of June 2014. So up to question number 3, we already seen this question paper. So let's start with question number 4a. First part, there is a part. Check whether V is equal to R2 is a vector space defined by the operations U plus V is equal to U1 U2 plus V1 V2, that is equal to U1 plus 2V1 U2 plus 2V2, and the scalar multiplication defined in this manner alpha into U1 U2, that is equal to alpha U1 minus 1 alpha U2 plus 2. This question was asked in 2 marks. So first of all, just try to understand the question and the behind this question what the needed part. So here we want to prove or we want to check that the given set is a vector space or not under this addition and scalar multiplication. Now to prove vector space, what we have to check? We have to check 10 number of conditions. First 5 conditions are for addition and the another 5 conditions are for scalar multiplication. So first 5 conditions, in first 5 conditions, that you know that first one is closedness, that means if U belongs to V, if U belongs to V, set V, V belongs to small v belongs to set V, then U plus V belongs to set V, that is the first condition. Second condition is commutative law, that is U plus V is equal to V plus U. Third condition is associative law, U plus in bracket V plus W, that is equal to in bracket U plus V outside the bracket plus W. The fourth condition is identity, that is for any U belongs to V, U plus theta, where theta is our 0 element, U plus theta is equal to U, that is equal to theta plus U, that is a fourth condition. The fifth condition is inverse exist, that means for any U belongs to V there exists minus U belongs to V such that U plus minus U is equal to theta. So these 5 conditions are for addition. Next 5 conditions are for scalar multiplication. Alpha, where for any alpha belongs to R or scalar, where alpha is a scalar, and U belongs to V, alpha into U must be belongs to U. Then for distributive law, alpha into U plus V, that is equal to alpha into U plus alpha into V. Then alpha plus beta in bracket alpha plus beta into U, that is equal to alpha into U plus beta into U. Then in bracket alpha beta U, that is equal to alpha in bracket beta U, that is equal to beta in bracket alpha U. So that is a ninth condition, and the last one is 1 into U, that is equal to U. So if this all 10 conditions are satisfied, then we can say that our set is a vector space under the given addition and scalar multiplication. So similar type of question here, we want to check that the given set is a vector space or not. But in this case, if you already know that this particular property, this particular condition is not satisfied, then directly you can explain that condition and say that this set is not a vector space, right? You don't need to check one by one all the conditions. If you know that suppose if you know that the third condition is not satisfied, then directly you can check directly you can prove that third condition, and you can say that this set is not a vector space. So similarly here you can see this is our set V is equal to R2 with this addition and scalar multiplication which I told you. Next is, see, this commutative law is not satisfied here. You can see U plus V is equal to, by definition, U1 plus 2V1 U2 plus 2V2. V plus U is equal to V1 plus 2U1 V2 plus 2U2. So clearly u plus v is not equal to v plus u. So v is not a vector space, right? Then this question was asked in 2 marks. The next part of this question, the B part, where S is equal to x1, x2, x3, where x1 plus 2x2 is equal to 1. Check whether S is a subspace of R3 or not, right? You can see this set is a subset of R3 clearly, because in this set all the vectors have 3 coordinates, and those type of vectors from R3 such that x1 plus 2x2 is equal to 1, right? Now when x is equal to x1, x2, x3 belongs to S, and x1 plus 2x2 is equal to 1, y is equal to y1, y2, y3 belongs to S, and y1 plus 2 y2 is equal to 1. Now let's check x plus y. X plus y, that is equal to x1 plus y1, x2 plus y2, x3 plus y3 not belongs to S. Why this x plus y not belongs to S? Because of, to prove that this x plus y belongs to S, what we have to check, that the first coordinate plus 2 into second coordinate, that is equal to 1. So x1 plus y1 plus 2 x2 plus y2, that is equal to x1 plus 2x2 plus y1 plus 2y2, that is equal to 1 plus 1 equal to 2, but that is not equal to 1 clearly. So clearly this set x plus y is not belongs to S, because if this is belongs to S, x plus y belongs to S, that means what? The first coordinate plus 2 into second coordinate must be equal to 1 by the definition of the set, right? You can see what type of vectors are in the set. Only those type of vectors from R3 are in the set such that the first coordinate x1 plus 2 into second coordinate x2, that is equal to 1. So if you want to prove that this x plus y belongs to S, definitely we have to check that the first coordinate plus 2 into second coordinate must be equal to 1, but that this thing not happen here. So that's why this x plus y not belongs to S, and S is not a subspace. Next part, question 4a, second part. Express px is equal to 6 plus 11x plus 6x square as a linear combination of the following p1, p2, p3, where p1 is equal to 2 plus x plus 4x square, p2 is equal to 1 minus x plus 3x square, and p3 is equal to 3 plus 2x plus 5x square. So 6 plus 11x plus 6x square, that is equal to a into 2 plus x plus 4x square plus b into 1 minus x plus 3x square plus c into 3 plus 2x plus 5x square. So here we want to express this polynomial. You can see all polynomial are 2 degree polynomial, okay, and we want to check that this p is this p can be expressed as a linear combination of this p1, p2 and p3. So that's why we are starting with, suppose this polynomial p can be expressed as linear combination of p1, p2 and p3. That means what? This p 6 plus 11x plus 6x square, that is equal to, here we use linear combination of p1, p2, p3 using the constant a, b and c. So if we can find such a, b and c, that means what? Definitely we can express this polynomial as a linear combination of p1, p2, p3. So 6 plus 11x plus 6x square, that is equal to a into 2 plus x plus 4x square plus b into 1 minus x plus 3x square plus c into 3 plus 2x plus 5x square. So 2a plus b plus 3c is equal to 6. A minus b plus 2c is equal to 11. 4a plus 3b plus 5c is equal to 6. To solve, we are using augmented matrix. The first row is 2, 1, 3, 6, right? The first row is 2, 1, 3, 6. That is exactly the coefficient of a, b and c from the first equation. The second row is exactly the coefficient of a, b and c from the second equation, 1, minus 1, 2, 11. And the third row is coming from the third equation, 4, 3, 5. This is 6. Now we have to convert this augmented matrix into a row echelon form, right? What is the meaning of row echelon form? That you should know. Again I want to explain that what is the meaning of row echelon form. In row echelon form, what we have to do, the first, if suppose there is our matrix, right? First of all, you have to find the leading entry, the first non-zero element, that is our leading entry, right? So suppose you are starting with the first row and first element is 0, then you have to pick the second element of that row. If that is a non-zero, then that is your leading entry, right? So now you can understand that what is the meaning of leading entry. Sometimes we call it pivot. Now below that leading entry, in that particular column, all the elements should be 0. That is the first condition. Second condition is if there is any 0 row, it should be the bottom of the matrix, right? And the third condition is whenever we are going from above to below in any matrix, our leading entry is always going from left to right. Okay, whenever we are going from above to below in any matrix, in that matrix, row echelon form matrix, our leading entry is going from left to right, not going from right to left. Okay, so if these three conditions are satisfied, then we can say that our matrix is in row echelon form matrix. So let's try to convert this augmented matrix into a row echelon form matrix. Using that row echelon form matrix, now we can easily find the value of a, b and c. So that is our target. Okay, so let's see how we find a, b and c. This is our augmented matrix. Now first of all, we are interchanging. Normally we are using as a leading entry as a 1. Why? Because we can easily convert, we can easily make a 0 below that leading entry, right? So if there is our leading entry is 1, it's quite easy to make a 0 in that particular column below that leading entry. So that's why first of all we are interchanging first and second row. So R12, that means we are interchanging first and second row. So now our first row is 1 minus 1 2 11, the second row is 2 1 3 6, and the third row is as it is 4 3 5 6. Now this is our leading entry, right? We are converting, we want to make 0 here below that leading entry, so that's why we are multiplying first row with minus 2 and add into the second row, and next we are multiplying first row with minus 4 and add into the third row. So the first row is as it is, 1 minus 1 2 11, the second row becomes 0 3, okay, because we are multiplying minus 2. So this minus 1 into minus 2 2, 2 plus 1 3, then minus 3 minus 4 minus 1, then 6 minus 22, so that will become minus 16. Then next we are multiplying first row with minus 4 and add into the third row, 0, then 7, then you can see when we multiplying first row with minus 4, 4 plus 3 7, then minus 8, 5 minus 8, that is minus 3, then 11 into minus 4 minus 44 plus 6, you will get minus 38. Okay, now this is our leading entry. See, this is our leading entry in first row. Below that leading entry we have now 0. In second row this is our leading entry. Below that leading entry we want to make 0 here, so that's why we are multiplying. Next process is we are multiplying second row with minus 7 by 3. Why we are multiplying minus 7 by 3? Because when we multiplying this 3 with minus 7 by 3, 3 will be cancel out, and then we add into the third row. So 7 minus 7 becomes 0. So that's why we are multiplying second row with minus 7 by 3. Okay. So the first and second row are as it is, 1 minus 1 2 11, 0 3 minus 1 minus 16, then 0 0. You can see 3 into minus 7 by 3. So 7 minus 7 0. Then minus 7 by 3, minus 1 into minus 7 by 3, 7 by 3, minus 3 plus 7 by 3. Okay, minus 3 plus 7 by 3. So 7 minus 9 by 3, minus 2 by 3, and then minus 16 into minus 7 by 3, that is 16 into 7 by 3. Okay, and minus 38. So when you solve it you will get minus 2 by 3. That is also you will get minus 2 by 3. So now you can see this matrix is now in row echelon form matrix, because this is our leading entry. Below that leading entry we have all 0. In second row this is our leading entry. Below that leading entry we have 0 here, and in third row this is our leading entry. Right, all the conditions are satisfied to become a row echelon form. Leading entry is going from left to right. Below that leading entry we have all 0, and there is no 0 row, so no need to convert our 0 row into a bottom of the matrix, so because there is no 0 row. So now this is a row echelon form matrix. Now using this row echelon form matrix we can find A, B and C. The equations are become, from the first row our equation become 1 minus B plus 2C is equal to 11, right?